We should now appreciate the flexibility and complexity of options available when using a digital SLR camera. It is important to become familiar with the effects and relationship between the three main elements of image capture, those being the sensor sensitivity or ISO, the exposure duration or shutter speed, and the amount of light entering the camera or aperture setting. There are a number of shooting strategies that affect the balance of these elements to obtain certain effects. The two we will discuss here are freeze frame and depth of field. To capture frozen movement, we want to speed up the capture speed, which means increasing the shutter speed. In this instance, at a normal ISO level and the aperture opened right up, we can achieve a 1:100 second shutter speed for correct exposure. To freeze the motion with the available light in this instance was not adequate. Still using the available light, and to try and capture the moment, we increased the ISO to a maximum of 3200, which gave us a 1/322nd shutter speed to maintain correct exposure. Though we have almost frozen the motion, it is still blurred. The amount of available light could be increased so we can speed up the shutter some more, but the problem with the poor image clarity in this instance is down to the very high ISO setting, which has introduced quite a lot of image noise. One way we can freeze movement and augment the amount of light is to use a flash. Most digital SLR cameras have a small built-in flash, which is designed more as a fill-in or secondary flash. The flash significantly increases the amount of available light, but it does so at a cost. Flashlight is harsh and casts stark shadows. It is not the increase in light alone, though, that has frozen the movement, as you can see that the shutter speed has just come down to 1/200th of a second. It is rather the strobe effect of the light that gives an instantaneous blast of light, and it is the flash that is freezing the movement, and not just an increase in the light itself. In order to mitigate the effect of the harsh flash, and to get an effect where the motion is both frozen and blurred at the same time, we can wind down the flash intensity and slow down the shutter speed at the same time. The effect is that the strobe of the flash freezes the movement, but keeping the shutter open longer also captures some of the movement of the object as a blur. Further improvements to this image could be achieved if we started closing down the aperture and slowing down the shutter some more. This would both increase the blur and provide a better depth of field when the strobe of the flash went off. So again, you can see with the same camera and camera placement, but with a variety of settings, we can achieve different versions of frozen movement utilizing similar capture strategies. Depth of field is one of the more tricky optical concepts associated with digital SLR photography. Essentially, depth of field is determined by the way light bends through the lens and is captured on the sensor surface. If the aperture is open to the widest extent, the light is bending the most through the lens, but if the aperture is closed up, the amount of light bending is significantly reduced. When we close the aperture down, as per the top diagram, we have less bending, and the result is a wider focal range or depth of field. The bottom diagram shows the aperture opened up and creating more bending, which results in a much narrower focal length or a shallow depth of field. When deliberately working with a shallow depth of field to push the background or foreground out of focus, you will need to focus the lens manually. The auto and manual focus switch is usually located on the side of the lens. The outer lens ring can be moved freely of the focusing motor once the autofocus is turned off. Don't try to manually focus the lens with the autofocus still on, as you may damage the lens and you cannot control the focal point precisely. In this next sequence of images, we will show you how using an open aperture allows us to focus either on the foreground, middle ground or background cube independently. In this first image, the foreground cube is the only one in focus. Using the same settings, we can then focus on the middle cube And finally, we can focus on the cube in the background. The exposure settings were the same in each instance. However, because the shooting strategy allowed us to achieve a shallow depth of field, because we have an open aperture, we are able to control where exactly we focus in the image. To maintain the widest focal range, we need to close down the aperture as much as possible. We then need to compensate the exposure with a longer exposure time. In this instance, we have gone to 1/5 of a second, which means we need to shoot on a tripod. You can use the autofocus when shooting with a small aperture and focus in the distance, as we can be assured all parts of the scene will be in focus. We could further improve this image if we added some more studio light combined with a reduction in ISO down to 100. For crisp, well-focused architectural model photos, the strategy is to use a tripod, to have the lowest ISO possible, to close the aperture down, and use studio lights to help increase the light and the exposure. The same scene here and lighting conditions have been photographed with variations in depth of field to give quite different results. One last thing to add when shooting very long exposures, as would be the case when shooting architectural models, it is prudent to use the self-timer so that you eliminate the risk of camera shake at the point when you press down on the shutter.